Hi guys, I am Teacher BOAZ in your lovely room again. So from our yesterday's lecture, there were some students who asked, how do we integrate or how do we differentiate the arctan, the arc cos, and the sine inverse? So I'll show them. I can see there are so many people streaming online, so you can also check what I'm going to show them how to differentiate. A good example gave me y is supposed to be the sine inverse of x. Y is equal to the cos inverse of x. Then the tan y is equal to the tan inverse of x. So there were three questions that they asked me to answer, which I'll show you today how to go about them. And this is a very easy concept in the sense that, let me subdivide where we are working. Now, when you've been given the sine inverse, the cos inverse, and the tan inverse, the most direct way is always to go back to the basics of calculus. Now, what you're supposed to do here, you come and say, if y is equal to the sine inverse of x, so you take sine both sides. So if I take the sine of y becoming x, because the sine of the sine inverse cancel, like taking the reciprocal of a number times that number, which is like the reciprocal of 4 is a quarter times 4 is 1. So the same, we are going to apply the knowledge here. Then by having that, remember, as I always teach you guys, you must always go back to basics. Let this be your angle in degrees. But remember, the a squared plus b squared is c squared. I'm taking you back to middle school, so you go back to the basics. Now, by having it here, you all know what we call SOHCAHTOA. SOHCAHTOA simply means the sine of an angle theta should be opposite of hypotenuse. The cosine of an angle theta is adjacent of hypotenuse. And the tan of an angle theta is supposed to be opposite of adjacent. Let me set my clock. Now, we want to come and say that whenever I want to get sine, so sine of y, remember these are all number x, we can put it over 1. Then say, since sine is opposite of hypotenuse, the opposite to this y as an angle becoming x, hypotenuse becoming 1. Then we can get the adjacent by the Pythagoras theorem, that the hypotenuse squared minus the height squared under the square root, providing the base, which is like the root 1 minus x squared. So here becomes 1 minus x squared under the square root. I hope you got it well. Now, by having it at that point, we come now and take the derivative both sides. We get the dx of the sine y becoming dx of x. But remember yesterday's lecture, I taught you that when you differentiate sine, the dx of sine of an angle becoming the cosine of that angle. So we are going to get here to be the dx of sine y. Remember, it is the sine of y. So we are differentiating with respect to y again. So we are going to get the cos y dy by dx. Remember, we are introducing dy by dx because it is y. It is the dependent variable. And when you differentiate dy by dx, you simply get 1. Then we can easily divide both sides by cos y by cos y. Now the cos will go. Allow me to transfer it here. So anytime you want to get the dy by dx, you simply get 1 over cos y. Then you go back to your triangle and ask, how do we get the cosine? The cosine of y should be adjacent divided by hypotenuse, which simply means 1 over cos y becoming adjacent, the square root of 1 minus x squared over 1. Okay? So your dy by dx should be equal to 1 over the square root of 1 minus x squared. That's now the derivative of the sine inverse. Remember, our y is the same as the sine inverse. So we come and write the dx of y, and my y is supposed to be the sine inverse of x, now becoming 1 over square root of 1 minus x squared. So those guys who are online, please just check with me. The dx of the sine inverse, now we get it to be 1 minus the square root of 1 minus x squared. Now, allow me write down here. Now, when you go back again, now we work for the y. If y is supposed to be the cosine inverse of x, we do the same. We take the cos both sides, which implies the cos of y becoming the x, because I'm taking both sides. Allow me transfer my working here. Then by knowing the cosine of y becoming x, you can put your x over 1 because it is a whole number. Then you go back to a trigonometric ratio that the cosine of an angle should be adjacent over hypotenuse. Okay? Now by coming it here, which means this triangle we had used it here, so we have to redraw another right angle triangle. So allow me have another right angle triangle here. Let this one be y, and we already know that the cosine of y becoming x over 1. Then the cos is adjacent to this becoming x, hypotenuse becoming 1. So here becoming 1 minus x squared under the square root. Remember the Pythagoras theorem. Then we take the derivative both sides, the dx of cos y becoming ddx of x. But the derivative of cos, I taught you yesterday, should be negative sine of that angle. So we get negative sine y dy by dx. And you know very well why I'm taking dy by dx, because I'm differentiating with respect to the independent variable, which is y. So we equate it to be 1, then divide both sides by negative sine y by negative sine y. This one will go. Your dy by dx becomes 1 over negative the sine of y. But you all know what we get the sine. Sine is simply opposite over hypotenuse. The opposite of y is 1 minus, so we take 1 over 1 minus square root of x squared, then which is a negative. So this is the derivative of the cos inverse of x. Because the y is the same as this y. So we can still write the dx of the cosine inverse of x becoming to be negative 1 over the square root of 1 minus x squared. So I've shown you how we get the ddx of cos inverse of x and the sine inverse of x. Now, when you want to work for the tan, the identities don't change. The concept is just the same. So you come and say if y is equal to the tan inverse of x, I take tan both sides, so tan of y becoming the x. Then we come and say, what does SOHCAHTOA states? That the tan of an angle y becoming opposite. The opposite of y is x over adjacent. Now this one, now we transfer it here to be 1. So here we have the 1 squared plus x squared under the square root, based on the simple Pythagoras theorem. Then coming here, we come and say, we take the dx of the tan of y becoming the ddx of x. But remember, when you differentiated a tangent, we got the sec squared that value. So we are going to get the sec squared y dy by dx becoming 1, because this derivative providing 1. Then you divide both sides by sec squared y by sec squared y. The sec squared y will go. Allow me transfer it here. So our dy by dx becomes 1 over sec squared y. But remember, there are some basics that I had taught you before. Allow me rub this end so that I also explain. Now, there's another important principle that says 1 over sine x becoming cosec x. That's rule 1. Rule 2, 1 over cos x becoming sec x. Then 1 over the tangent of an angle x becoming the cotangent. We call it the cot x. So these are 3 very important identities in the trigonometric differentiation, or the calculus of the trigonometric values. Now you come and say, instead of writing 1 over sec squared x, sec squared y, remember the sec is here. Whenever you want to get sec, it's 1. The sec is 1 over cos. So you just come and replace it to be 1 over the cos. But remember, you have to square it because we take the cos squared x. Because we know that whenever we take 1 over cos x, we get the sec squared x. But the sec squared x was the derivative that we had gotten at this part. So basically speaking, we are going to get it to be dy by dx becoming 1 over, remember it is 1, or it's like taking 1 divided by 1 over cos squared y, which is the same as 1 times cos squared y divided by 1, which is cos squared y. So coming here is like having to be the cos y, we put in bracket squared. Because I explained to you in my previous lectures, we do not square the angle, but we square the trigonometric ratio. Now coming here, we come and say the dy by dx becomes, how do we get cosine? From the word SOHCAHTOA, adjacent over hypotenuse. My adjacent is 1, and my hypotenuse is 1 plus x squared. Remember, we are squaring everything from this trigonometric identity. When you square the square root, it cancels. So your dy by the dx becomes 1 over 1 plus x squared. So it means my y was definitely the tan inverse of x. So it means when you get the dx of the tan inverse of x, the answer becomes 1 over 1 plus x squared. So those are the three derivatives. Those are the three derivatives of what we were doing here. So you know how to derive, to differentiate tan inverse of x, sine inverse of x, and the cos inverse of x. So I've just answered those people that had posted their questions online. So I'm going to introduce to you a concept which is also very important, because you know in my lectures we just go through the questions relying on the basic principles behind the mathematics you've all learned. Now, the concept I want to introduce is simple. I want to introduce something called the hyperbolic functions. We call them the hyperbolic functions. Now, whenever we talk about hyperbolic functions, those people in the A levels and also at the university, you know very well that the exponential functions, the EX, so there's a way we can take the function EX and E negative X. When we take the EX and the E negative X under the hyperbolic functions, there is a way they can be combined to form a strong trigonometric function, or what we call the circular functions, to provide some motion. So how do we go about it? Remember, when you take the E, when I take the E power x plus the E negative x, I divide by 2. If I take a half of the summation of those exponential functions, we get what is called the cosh x. We denote it by cosh, cosine, cosh. We introduce h. Then, if you take the half of the E power x minus the E negative x, we get what is called the sine, sine x. So that is the hyperbolic function, when you get a half of the difference between E x and E negative x. Then from here, I've introduced the first concept, the second. Now the third one, you all know what I taught you, that whenever we take the sine of an angle x over cos x, we always get the tan x from the ordinary basic trigonometric function. Now, can we find the tan x? So we come and say, for you to get the tan x, you will simply take the sine x over the cos x. But the sine x becomes a half into E power x minus E negative x divided by half into EX plus E negative x. Then the half will go. Okay? Then at that particular concept, we can divide everything else in that by the E negative x. So if I take the EX here, divide by E negative x, then I take this E negative x over E negative x, that is the upper part. Then the lower part, I take also the E power x over e negative x, then e negative x dividing by e negative x. We are dividing everything by e negative x. So we come and get, remember, it's like dividing e power x divided by e minus x. What you learned in middle school, that whenever you divide indices having the same base, different powers, you minus. So x minus minus x becomes 2x. So I'm going to get e 2x minus, this one will cancel because it is the same, over e 2x minus 1. No, the lower part was plus 1. Now, whatever we have here is now what we call the tan x. That is now what we call the tan x. I'm checking my timing for the recording. Now you see the e2x minus 1 over e2x plus 1 is called tan x. So these are what we call the hyperbolic functions of what I've generally formed here. So if anytime somebody ever asks you cos x is e power x plus e negative x over 2, the sine x, ex minus e negative x divided by 2. So these are basics, because somebody can come and ask you in an exam, the moment they've given you such an equation, they can come and ask you find x. If somebody come and ask you that find x, find the value of x if tan x, this tan x, somebody comes and say let it be half. How do you find the tan x if you've been provided it to be a half? Allow me to wrap this point and explain that simple concept. It is very easy and is very much applicable. Students who will be taking engineering maths, will be taking actuarial science, will be taking architecture. Make sure that you get the basics to the latter. Now you come and say the tan x becoming half, but tan x is equal to e2x minus 1 over e2x plus 1 is equal to 1 over 2. You can put the parenthesis, then cross multiply. So 2 into e2x minus 1 becoming e2x plus 1. Then 2e2x minus 2 is equal to e2x plus 1. So we can collect like terms 2e2x minus e exponential 2x is equal to 3. Then if we minus, we get e2x becoming 3. But if you know that e2x is 3, that is called the natural log or the ln. So we introduce the Napierian, the natural logs on both sides. Take the ln of e2x should be ln of 3. Remember, the ln of the exponential cancel is like the log of the antilog. So this goes with e. So your 2 power x becomes the ln of 3. Then your x become the ln of 3 divided by 2. So this is the solution for x, if they were to ask you that. So you see how simple and how basic it becomes. So majorly at times to the students I teach maths, for you to score good grade that leads you to a career, stick back by the definition. I remember most of my students were asking me, what do you mean by definition? Which simply means you go back to the basics. Are we okay? Hi guys, I am BOAZ, a mathematics teacher. I want to show you some of the ways to differentiate a trigonometric function. Now, if somebody provides y is equal to sine of x, I know many a times you've always been taught by your mathematics teachers, this now right from the A levels, that when you get the d dx of the sine of x, you get the cosine of x. And now I want to prove to you why is it that the derivative of the sine of x becomes, let me set my stopwatch. Why is it that the d dx of sine of x becoming cos x? And we also know the d dx of the cosine of x becoming the sine x, which is a negative. So I'm giving you some of the rules, then we go back to our mathematical constitution, then we work it out. Now this is how you should work it out. An example, if you have an x and y, maybe it is a sinusoidal wave or a curve. We just consider the small change in x and small change in y, which we call del y or del x. Now, we are going to say let y increase by small change in y, then let x increase by small change in x. Then we know the change in y, change in x, from what you are taught from the basic level, that change in y by change in x provide the gradient function. Now we come and say our del y becomes the sine into x plus del x minus y. We are doing the subtractive inverse. I minus y the other side, but my y was supposed to be sine x. Now at this stage, it takes me to a very important property to remind you. Remember when you have the sine of p minus the sine of q is the same as twice the cosine of p plus q over 2 times the sine into p minus q over 2. This is a rule, but we can prove it numerically from the algebra to numerics. Maybe if you take your p to be 60 and your q to be 30, you can pause my videos and check from your calculator. Me already have them in my mental software. So we come and say the sine of 60 minus the sine of 30. We all know mathematically sine of 60 is 0.866, sine of 30 is 0.5. When we get the difference, we get 0.366. Then I want to justify from the numerical to this rule. Does it also work for the twice cos p plus q over 2 times sine p minus q over 2? This is specifically to the A-level students and those doing the engineering mathematics and even architecture at the university. So we can write twice the cosine p plus q. 60 plus 30 is 90. 90 divided by 2 is 45 times sine of p minus q. 60 minus 30 is 30. 30 divided by 2 is 15. Then the cos of 45 from the atmosphere of maths should be 0.701. The sine of 15 should be 0.2588. 2588. Then if you use your calculator and multiply the numbers, you will get the answer is 0.366. You can pause the video and check if the two numbers justify. So it is indicated that whenever you have the sine of p minus sine of q is the same as twice cosine p plus q over 2 times sine p minus q over 2. As simple as the constitution of maths justify. Then you come here and say, instead of writing here, I'll write the del y becoming the twice the cosine into x plus del plus x, which is twice x plus del x over 2 times the sine. I'm using that identity into p minus q. So if I minus, I will get the del x divided by 2. Then we divide both sides by del of x by del of x. This is by the definition of the gradients. Then reaching at this point, we come and take the limits. You take the limits of del y by del x into twice the limits of the cosine. Remember 2x over 2 becoming x plus del x over 2 times the sine of the del x over 2. Then we take by del x. We are taking the limits of everything else. But remember, there's another important identity that I would love to remind you, which is very, very basic. When you joined your year 12 and 13, your teachers must have introduced and shown you that the limit of the sine of an angle theta over theta as theta turns to 0 is always equal to 1. This is a very important identity. So remember, maths needs maths to help each other. You see? Then we come here and say our limits of del y by del x as I take the limits should be equal to, but we can rewrite this to be, because we already know twice the limit the cos x plus del x over 2 times the sine of del x over 2. Now I can bring this 2 here. Remember, when you multiply by a number, it's like dividing by its reciprocal. So I put here to be del x over 2. So these 2 will cancel. Then as you take the limits, apply the rule. This is equal to 1. So we get the limit of del y by del x becomes the dy by dx becomes the cosine into x plus del x over 2. But remember, our del x was tending to be 0. Our del x, where did we write it? We did not indicate that as our del x tend to 0, as our del x tend to 0. So become 0 over 2. So this results, your dy by dx becomes the cosine of x. So I've proven that theorem from your calculator that many a times you get the d dx of sine x to get cos x. So we use by first principles. In fact, what I'm defining for you here is called by first principles. And this one goes to the people in A levels, even my students in A levels across. From international baccalaureate to Cambridge to American system, it doesn't matter. The maths rules do not change, even at the university. You will still apply them. Now, there are also some of the principles that you need to have known, some of the basics. We all know that whenever we take the sine, the tan theta is always sine theta divided by the cosine theta using the trigonometric identity. Then 1 over sine theta become cosec theta. Then 1 over the cosine theta becoming sec theta. Then 1 over the tangent theta becomes the cotangent theta. So these are very important identities that you can use with your revision. Now, there is also something that touches on the double angle properties. Remember, when you are handling any maths, you must know all the mathematics constitution, the mathematics laws, the mathematics principles, all of them sums to be 1. It will help you to move from one step to another. And as I always teach, make sure you show the steps. Make sure you show the procedure. Don't just write the answer. Because if I was your teacher, I will give you a 0 if you write for me the answer without showing the steps, the processes. Now, when we have the sine of 2 theta, is there a way we can rewrite it? Yes. We can write sine of 2 theta to be 2 sine theta cos theta. And I can prove that one trigonometrically using the numerics. Now, what if we say that sine 2 theta decide and say to be sine theta plus theta, because theta plus theta becomes 2 theta. Then I come and say, let theta be maybe an angle, maybe theta, let it be 30. So the other theta will be 30. So sine of twice 30, sine of 60, 0.866, that is from your calculator if you have one. Can it be the same as twice sine of 30, because theta was 30, cos of 30? So I will take 2 times, the sine of 30 is 0.5 times cos of 30 should be 0.866. So 2 times 0.5 is 1.0, which is 1. 1 times 0.866 becomes 0.866. You see how easy it comes. Now there is another important rule I want to show you. Remember that the sine theta can be the same as the cosine into 90 minus theta. This is called the complementary property. That if somebody come and ask you maybe to find the sine of 30, it is the same as the cosine into 90 minus that 30. So the sine of 30 becomes the same as the cosine of 60. Because cos of 60 becomes 0.5. And the sine of 30 becomes 0.5. Because if you are to check your right angle triangle giving 2, 2, 1, 1, according to Pythagoras theorem, 2 squared minus 1 squared is the square root of 3, putting root 3 here. Then going back to your basics you learned in the middle school, SOHCAHTOA. So sine of this is supposed to be 60, 60, this is 30 and 30. So sine of 30 is supposed to be opposite over hypotenuse. Opposite is 1, hypotenuse is 2, which is 0.5. Then the cos of 60, cos is adjacent. Adjacent of 60 is 1, hypotenuse is 2. So we still get 0.5 without necessarily relying on those plastic calculators. We can use our minds, because one of the things I believe, the mind has been dexterously woven by God himself to constitute the academic texture, the academic architecture. So the more you use your brain in practicing, I'm talking to somebody preparing for exam now. Remember what we call the neuroplasticity of the brain and of the mind. The more you do, the more it covers. Remember, your brain can cover more than any computer can cover in the world. but we underuse our brain. We use maybe 1% of our brain. Try and use even 3%, then you will be very far. Okay? Now, I've already shown you that. So these are very important principles. How does that principle apply? An examiner may decide in exam and ask that sine 2 theta minus 30 is supposed to be equal to cos maybe theta plus 70. Then they ask you find theta. Just come to this identity that when I add these two angles, I should get 90. So if I take 2 theta minus 30 plus theta plus 70, I should get 90. So from here you can do your arithmetic. So 2 theta plus theta, not plus 3, this 2 theta plus theta. So we get 3 theta. So minus 30 plus 70 is plus 40. Is supposed to be 90. Now 3 theta becoming 90 minus 40, which is 50. Then I divide by the coefficient of the variable theta. Then my theta becomes 50 over 3, which is 16 2/3 or 16.66666. Or we write 16.67 because it is a recurring. It's not a terminating, it's a recurring decimal. So I've already shown you how some of those basics. Now allow me, I've now proven to you guys that the sine of 2 theta can be written to be 2 sine theta cos theta. Are we good? Now look here. What if we have the cosine 2 theta? Is there a way of rewriting? Yes. You can rewrite cos of 2 theta to be cos squared theta minus sine squared theta. But remember from your elementary school you are taught that whenever you take the sine squared theta plus cos squared theta, the answer was always equal to 1. So I'm taking this rule and planting it in the first equation. So by having the cos of 2 theta, which is cos squared theta minus sine squared theta. But I have sine squared theta plus cos squared theta is 1. So cos squared theta is the same as 1 minus sine squared theta, which is now I replace here 1 minus sine squared theta minus the other sine squared theta, which implies 1 minus 2 sine squared theta. So this is also the same as this. 2 sine squared theta. We are playing around with maths. Just let your brain juggle with it. Let the neuroplasticity, the function of that property be at work by practicing, guys. Or you can come and say your sine squared theta is 1 minus cos squared theta. So you come here 1 minus cos squared theta minus sine squared theta by simply replacing. Or you come here and say now I want to replace the sine. Sine squared theta is 1 minus cos squared theta. So cos squared theta here, if you take your cos squared theta minus sine squared theta, but sine squared theta is 1 minus cos squared theta. So we say 1 minus cos squared theta. Then you learned in your elementary school that minus minus is plus. So we get the 2 cos squared theta minus 1. So this is also the same as this. 2 cos squared theta minus 1 theta. Then you learned in your elementary school that minus minus is plus. So we get the 2 cos squared theta minus 1. So this is also the same as this. 2 cos squared theta minus 1. Yeah, so the thing is, so we can come and tell our teachers while you write for the exam that cos 2 theta is the same as cos squared theta minus sine squared theta, which is the same as 1 minus 2 sine squared theta, which is the same as 2 cos squared theta minus 1. So all this is a rule. It's a very simple identity. Now what if I give you the tan 2a? Can we write it to be tan a plus tan a over 1 minus tan a tan a? Then tan a plus tan a is twice tan a over, then 1 minus tan a tan a. Remember tan times tan is tan squared. Then we get the tan squared a. And I also taught you guys that we do not square the angle, but we square the trigonometric function. An example, if somebody put for you the sine squared theta, is the same as the sine of theta, then you square your answer. For example, if somebody asking you, what is the sine squared 60? It's like taking the sine of 60, then square it. But sine of 60 is 0.866. What do you get when you square 0.866? It's the same as root 3 over 2 squared. What is root 3 over 2 squared? Because square root of 3 is 1.732. Divide by 2, you get 0.866. So the square of the 0.866 is the same as the square of the square root of root 3 over 2, which is 3 over 4, which is becoming 0.75. Yeah. So when you square your 0.866 is the same as 0.75, which is basically a quarter. Please use your calculators and try that. I'm just using my mental software, so you can confirm from what I've just done there. So anytime you have your tan 2 theta, 2a is the same as 2 tan a divided by 1 minus tan squared a, which we can even prove trigonometrically. You can come and say, allow me rub this end so I may explain it in clarity to my audience over there. Even online, I can see so many people online. So if you take your a to be 15 degrees, so here somebody takes the tan of 2a is the same as 2 tan a over 2, not 2, over 1 minus tan. My stop clock says it's 3 minutes. Let's rush. Square. So we say this is like tan 30, which is twice tan 15 over 1 minus tan squared 15. But tan 30, I can go back to my, can we try this without a calculator? 2, 2, 1, 1. The Pythagoras, this 60, 60, 30 and 30, then 90. So the Pythagoras theorem, 2 squared minus 1 squared is the same as the root of 3. So we come and say the tan of 30 becomes, what does Sokatoa say? TOA. Opposite of adjacent. The opposite is 1 over root 3. But we know 1 over root 3 can be rationalized. The conjugate becomes root 3. So you multiply by root 3 over root 3, because even if it is negative, they cancel, right? So we have the root 3 over, root 3 times root 3 is root 9, which is 3. And from your plastic calculator, you get square root of 3 to be 1.732. If you divide by 3, 3 goes here 1, it goes 0.5744, 774. Yeah, so that is because 3 goes here 5, 0.5, 15, 23, it goes 7, 21, 22, say, yeah, it should be 0.5774. But you can justify, my time is up, but you guys, you get the tan 15 and the tan squared 15, which is the tan 15 squared. Because do not square the angle, but square the trigonometric ratio. So I'm walking you throughout the basics of math. These are the fundamentals of maths to people who are doing the A-levels. And I would encourage every student across the globe. You know, I'm an international mentor, so this is a very important point. Make sure that after your year 11, make sure that you go to A-levels. Even after your O-levels, go to A-levels. Because A-levels is where now you identify with your career. You get the fundamentals, so you can easily be accessed to any other international university.